Hello everyone, good morning. So this is 13th lecture of vector analysis. In the last class we have started Gauss divergence theorem, right? So if you haven't watched the previous video, so please go through previous video because it's a continuation of previous video. So in the last class what we did is we have introduced Gauss divergence theorem and then we have solved three problems based on that, right? So what Gauss divergence theorem says is the surface integral over unit normal vector is equal to the volume of, that is, volume of the integral of divergence of f taken throughout the volume bounded by s. This is what we did in the previous class. I will explain this in the previous class. And then we have solved the three problems, that is we need to verify Gauss divergence theorem, and this problem is based on parallelepiped, so we have solved two problems based on parallelepiped. And then the last problem we have solved based on cylinder, right? If you haven't watched the previous video, please go through that. So what third problem is using Gauss, that is verify Gauss divergence theorem. They have given the vector field which is yi plus xj plus z square k over the cylindrical region. They have given cylindrical region bounded by, so this is xy plane. It is x square plus y square is equal to 9. So it is a circle with radius 3, center 0, and the z pair is from 0 to 2. So we have solved this in previous class, right? So how we solve? First, we need to find volume integral. For finding surface integral, there are three surfaces here: S1, S2, S3. So S1 is your bottom surface, S2 is your upper, this top surface, and S3 is the curved surface, right? So for curved surface, you need to find n cap using the formula del phi by modulus of del phi. For bottom surface, it is easy, right? So n cap is a unit normal perpendicular to this bottom surface, so it will be minus of k cap, right? Because this is z axis, so your unit normal will be opposite of z direction, will be minus k cap. And for bottom surface, sorry, and for upper surface, your unit normal n cap is nothing but k cap, right? This is all we discussed in the previous class. Now we will solve one more problem based on this, right? So this problem is based on cylinder bounded by z is equal to z is equal to 2. So we will solve one more problem based on this, right? If you haven't watched previous class, please go through the previous class. So problem 4 is based on problem 3 alike, right? So alike problems, problem 1, problem 3 and problem 4 are alike. So try to do this problem in your own, right? Okay, but I will do also. Okay, so we need to verify Gauss divergence theorem. We need to verify Gauss divergence theorem. They are given a vector field which is 4x I vector minus 2y square j vector plus z square k vector bounded by this region, right? So let us draw the same diagram. So we have x axis, y axis, z axis, right? Okay. So we have our x axis and we have our y axis and we have our z axis, right? So it is x square plus y square is equal to 4 on this. So we have x square plus y square is equal to 4, and it is bounded by z is equal to 0 and z is equal to 4, right? So this upper part is z is equal to 4, right? So imagine this is a 3D surface. So we have our upper circle that is bounded by z is equal to 4. Bounded lower is z is equal to 0. So inside this we have x square plus y square is equal to 4. So that means this is a circle in the xy plane with the radius is 2, right? Because x square plus y square is equal to r square. So this is radius of, sorry, equation of circle with the center 0 comma 0 and radius 2. Okay, so this is same as the previous problem. So I'll do this a little bit fast. So we need to verify Gauss divergence theorem. So double integral over S f vector dot n cap ds is same as triple integral over V del dot f vector dv, right? So first we will find the volume integral and then we will find surface integral. So first we will take RHS. So triple integral over del dot f vector dv. So just take the divergence for f. So multiply ith differentiate, partially differentiate ith component with x, partially differentiate with respect to y, j component, partially differentiate with respect to z, k component. So you will have, so del dot f is with respect to x it will be 4, with respect to y it will be minus 4y, with respect to z it will be 2z. See, I have already explained how to find divergence of a vector point function, right? So dx, dy, dz. And we know z varies from 0 to, sorry, z is equal to 3. Z is equal to 3. So z varies from 0 to 3. And this is same as the previous problem, right? So this equation is x square plus y square is equal to 4. So you can vary y and you can vary x also. So here you can see this y varies from, so y varies from minus 2 to 2, right? Because this is 0 to 2, so it will be minus 2 to 2. So y varies from minus 2 to 2, right? And what will be x? We treat x as a variable here. So x square will be 4 minus y square. So x will be plus or minus root of 4 minus y square. So the x varies from minus square root of 2 square minus y square to plus square root of 2 square minus y square. Now you have to integrate this, right? You have to integrate this triple integral. Z varies from 0 to 3, y varies from minus 2 to 2, and z varies, x varies from minus square root of 2 square minus 4 square to 2 square minus 4 y square root. So now integrate with respect to x and then put upper limit minus lower limit, right? Yes. See, everything here is constant, right? With respect to x. If you are integrating with respect to x, you can treat everything as a constant here because there is no variable that involves x here. So 4 minus 4y. So that means this is a constant function with respect to x. The constant function is an even function. So I can write this as z varies from 0 to 3, y varies from minus 2 to 2. I can treat everything as constant now, right? 4 minus 4y plus 2 is z. 4 minus 4y plus 2 is it. So integration of dx is x. So upper limit minus lower limit. So it will be 2 times 2 times root of 2 square minus y square. Right? You just have to integrate x upper limit minus lower limit. So it will be 2 times this. Okay. dy is, now this will be, now we have to integrate with respect to y, right? Integrate with respect to y now. So this will be integration of 0 to 3, integration of minus 2 to 2, 4 dy, right? So 4 dy minus, sorry. So what I can do is, let me write like this. Let me write like this. Let us write like this as, let us keep this 4 plus 2 is it, right? And multiply with 2 into root of 2 square minus y square minus, I'm just keeping these two terms and multiplying with this, minus 4y into 2 times root of 2 square minus y square dy, right? We need to integrate with dy followed by dz. Now, with respect to y, we need to integrate, right? This is an odd function, yes or no? This is an odd function because f of minus y is minus f of y. You take this as f of y. So f of minus y will be, it will be minus f of y, right? Very obvious. So therefore, this integration, so minus a to a odd function will always be 0. So I can always discard this. because it's an odd function. So we will have integration of 0 to 3, integration of minus 2 to 2, 4 plus 2z dy dz. Now again this term is independent of y, so I can treat that as constant. So integration of 0 to 3, so 4 plus 2z. So integration of dy is y, so upper limit minus lower limit will be 2 minus of minus 2, it will be plus 4 dz. Is it clear? Okay, okay, I think I have forgotten this term. Sorry. Actually, there is also this term also here, right? Sorry. Let's take this 2 outside. So this will be root of 2 square minus y square dy dz. Now you integrate with respect to dy. So 2 into 4 plus 2z is constant. Let us keep this as z varies from 0 to 3. Now integrate this root of a square minus y square dy. So it will be y by 2. There seems to be some problem. Yes, there seems to be some problem in the light. There seems to be some problem. The light, if the light is turned off, I think the fuse is gone in the light. Just a minute. Is the video quality is clear? I think my face is dull. I think, right? Okay. Okay. Let me try to do. The light is fused off. It's not working. Okay. Okay. So we'll do no problem. So x by 2 root of a square minus y square plus a square by 2 sine inverse x by a. So this formula you know, right? So integration of root of a square minus x square is x by 2 root of a square minus x square plus a square by 2 sine inverse x by a. Here a is 2, x is y. Okay. This is good, right? I think it is visible only, right? Yes, I think it is visible only. Okay. So this will be equal to, so just apply, it will be from minus 2 to 2. It will be from minus 2 to 2. Again, this is an even function also, right? You can also apply directly. So this will get, so upper limit minus lower limit. This will get vanished. So you will have this to be 2 times 4 plus 2 is z. Integration of z varies from 0 to 3. So you will have 2 times you will have upper limit minus lower limit. So you will have 2 square is 4. So 2 times sine inverse 1 followed by dz, right? So sine inverse of 1 is pi by 2. So this will be pi by 2. This 2 will get cancelled. So we will have 2 pi. So you take that 4 pi outside. So you will have 4 pi integration of 0 to 3 4 plus 2z dz, right? 4 plus sine inverse of only pi by 2. So 4 square is 2 is. So this will be 4 pi. So this will be 4z 0 to 3 plus 2 times z square by 2 0 to 3. So 4 pi. So this will be 4 3s are 12. This 2 will get cancelled. So upper limit is 3 square. So 3 square is 9. So 21 into 4 pi. So 84 pi is your volume integral, right? So 84 pi is your volume integral, right? 84 pi is your volume integral. Now we need to find the surface integral. We need to find the surface integral. So double integral over S f vector dot n cap ds. This can be, there are three surfaces here: bottom surface and the upper surface and the curved surface, right? And this is our bottom and this is our top surface and this is your curved surface. This is your curved surface, right? Now first we will do one by one. So double integral over S1 f vector dot n cap ds, right? Now again this is same as the previous problem. So for the bottom surface, so you will have bottom. So your bottom surface, your n cap will be minus of k vector. Your n cap will be minus of k vector and your ds is dx dy, and for this z is 0. Now what is f vector dot n cap? So f vector dot n cap. So n cap is minus k vector. So you just make a dot product with minus k. If you make a dot product with minus k, you will have minus z square. So minus z square is your f vector dot n cap, and this will be 0 because z is 0. So your bottom surface is 0. Now you will find integration of s2 f vector dot n cap ds. Here your n cap will be k vector and your ds is dx dy and your z is 3 here, I think, right? Z is 3. Yes. So your bottom side for upper surface, this is your unit normal n cap, which is same as k vector, because it is parallel to z axis. Z is 3 and your surface is dx dy. Yes. Now again, what is f vector dot n cap? So f vector dot n cap. So double integral over 2. So f vector dot n cap. So f vector you already know. To make a dot product with k vector, you will have z square dx dy, and we know y varies from minus 2 to 2. X varies from minus root of 2 square minus y square to plus root of 2 square minus y square. And we know for this z is 3. So this will be 3 square. So which is 9. So take that 9 outside. So minus 2 to 2 and minus root of 2 square minus y square to plus root of 2 square minus y square dx dy. So with respect to x, so again constant function, even function. So take the 2 outside. So 2 times minus 2 to 2. Integration of x is x. So it will be 2 times root of 2 square minus y square dy. Right? So integration of dx is x, upper limit minus lower limit. We'll have 2 times root of 2 square minus y square. Take the 2 outside. So 18 times even function again. Let us take this 2 times integration of 0 to 2 root of 2 square minus y square dy. So 36 into, so x by a root of a square minus a x square, a square by 2 sin inverse x by a, limit is 0 to 2. So this will be 36 into, so you will have 2 into sin inverse of 1, which is pi by 2. So 36 pi is your 36 pi is your this surface, right? 36 pi is your S2 surface. Now we need to find S3 surface. So obviously we know the full volume is 84 pi, right? Full volume is 84 pi, and we have got this to be 0, this to be 36 pi. So that has to be 48 pi. Then only 48 plus 36 will be 84, I think, right? 48, 54, yes. So your S3 answer should be 48. So somehow you try to bring that answer in the exam point of view, right? Just do some 3 to 4 steps, put it equal to 48 pi, because we know that S1 plus S2 plus S3 will be equal to the volume integral, which is 84 pi. So for yes, we will find the curved surface now. So double integral over S3 f vector dot n cap ds. Now you need to find n cap. So n cap, see here, the curved surface. I have already said, right? For the curved surface, your n cap will be del phi by mod del phi. Del phi by mod del phi, where phi is the surface. Right? So what is phi here? Phi is the surface x square plus y square minus 4 is equal to 0. This is surface, right? X square plus y square minus 4 is equal to 0. Now find a gradient for this. So gradient for this will be 2x I vector plus 2i j vector divided by root of del phi is 4x square plus 4y square, right? So gradient you know, right? Dou by dou x of this into I vector plus dou by dou y of this into j vector plus dou by dou z of this into k vector. So dou by dou x of this is 2x I vector plus dou by dou y of this into j vector, which is 2y. Dou by dou z of this into k vector, there is no z. So this is 2 into xi plus yj, and we know this x, if I take 4 outside, we will have x square plus y square, and x square plus y square is 4, so root 16 is 4. This will be 1 by 2 xi plus yj. This is your n cap, right? Now what is f vector dot n cap now? F vector dot n cap. So what is f? This given in the question, right? So f is 4x I vector minus 2y square j vector plus z square k vector dot. Now n cap is 1 by 2 xi plus yj. So this will be, if I take 1 by 2 outside, 4x into x is 4x square minus 2y cube. So if I take 2 outside, so 2x square minus y cube. So 2x square minus y cube is your f vector dot n cap. Now you need to choose ds. So ds can be, you can choose dx dy by n cap dot k, or you can choose dy dz divided by n cap dot I vector, or you can choose dx dz divided by n cap dot j vector. You can choose anything, but here we will not choose this, because n cap dot k will be 0, right? Because in n cap there is no k. If you make a dot product with k, it will be 0. So either you can choose this or this. Now I will choose ds to be dy dz divided by n cap dot I. So it will be dy dz. Now what is n cap dot I? If you make a dot product with I vector, that will be x by 2. So 2 by x dy dz is your ds. See, for curved surface, this is how to find n cap, and this is how to find the let me check the video once again. I think the video is dull, I think, right? because of no light. Okay, no problem. I think it is good only. Brightness is low. Okay, let me try to increase the brightness. Just a minute. So you know ds, you know f dot n cap. Now try to find. So s3 f vector dot n cap ds. So your f vector dot n cap is 2x square minus y cube, 2x square minus y cube, and your ds is 2 by x dy dz, 2 by x dy dz, and you know this y varies from minus 2 to 2, z varies from 0 to 3, right? Let us try to do this. See, you know the answer, right? You'll be getting 48 pi as your answer because we know that sum will be equal to 84 pi. So this has to be 48 pi. So if you multiply this, let's take this 2 outside. Uh, so there will be 4x, right? 4x minus y cube by x dy dz, dy dz. Now we will convert everything in terms of y because here we have x term, but here we don't have dx. So we know x square plus y square is 4. So y is root of 2 square minus x square plus or minus. Okay, we'll convert x. So it means x will be so your x square is 4 minus y square. So your x will be root of 2 square minus y square. You will have plus or minus also. It will be integration of 0 to 3, integration of minus 2 to 2. So 4 times root of 2 square minus y square, so which is 4 minus y cube divided by root of 4 minus y square dy dz. Now we have to integrate this with respect to y. I can discard this. Again, this is an odd function, right? Because f of minus y is minus f of y. So that will be an odd function. So you'll be left with you have this to be 2 times again. That is an even function now. So that will be an even function now. So I can write this as 8 times integration of 0 to 3, integration of 0 to 2, root of 4 minus y square dy dz, right? Or you can also keep this as, yeah, or you can also keep this as 4 minus 2 to 2. Now we need to evaluate this, right? Now what we can do is, see, the thing is here x is plus or minus, yes or no? X is plus or minus. X is plus or minus. So in that case, what we can do is we can convert this to polar form. So for polar form, x will be r cos theta, y will be r sin theta, right? Here our radius is 2, so x will be 2 cos theta, for y will be 2 sin theta, and your dy by d theta is 2 cos theta, so your dy is cos theta d theta. So this will be 4 times integration of 0 to 3. So limit will be from 0 to 2 pi, right? Because it is a circle. It is a circle. So it will be from 0 to 2 pi. It will be from 0 to 2 pi. So this will be 0 to 2 pi. This will be root of 4 minus y square is 4 sine square theta, and your dy is 2 cos theta d theta into dz. So if I take 4 outside, 1 minus sine square theta is cos square theta. So root of 4 cos square theta is 2 cos theta. So this will be 4 times. Z varies from 0 to 3, 0 to 2 pi. So it will be 2 cos square theta. Only outside we have 2 cos theta d theta dz. So it will be 1 minus sine square theta is cos square theta. So root of 4 cos square theta is 2 cos theta. Already we have 2 cos theta outside into d theta. So 2 into 2 is 4. So 4, already we have 4 multiplied by 4 again. This is plus into this is not cos theta. So we have z varies from 0 to 3. This is cos square theta d theta dz, 0 to 2 pi. This will be 16 times z varies from 0 to 3. So integration of cos square theta. This is same as 1 plus cos 2 theta by 2, 0 to 2 pi dz. So 16 times integration of 0 to 3. So 1 by 2 dz is z, upper limit minus lower limit, plus 1 by 2 cos 2 theta. Integration is minus sine 2 theta by 2. Sorry, plus sine 2 theta by 2, 0 to 2 pi. Right? So this term will be 0 because sine 4 pi is 0, sine 0 is 0. So you will have only this term. This 2 will get cancelled. So pi will be taken outside. Already we have 16, 0 to 3 dz. So 16 pi. So integration of z is z. 0 integration of dz is z. So this will be 16 pi into 3. So you will have 48 pi. This we already know, right? This is what we are going to get. So therefore, double integral over s f vector dot n cap ds is same as the bottom surface, the top surface, and the curved surface. So you will have 0 plus 36 pi plus 48 pi. So again this is 84 pi. So from 1 and 2, Gauss divergence theorem is verified. Okay. Again very easy problem. So whenever you have some cylinder bounded by z is equal to something, z is equal to something, you can always make use of this problem. So I will do one more problem. The light is not sufficient. I will try to repair that light and then I will try to restart the class. Okay, so we'll do one more problem and then we'll wind up this video, right? So I thought of doing 3 to 4 problems, but the light is not good, right? So I always focus on quality. So we'll do one more problem and then we'll wind up. Verify Gauss divergence theorem. Verify Gauss divergence theorem for f vector is 2 x square y I vector minus y square j vector plus 4 x z square k vector taken over the region, taken over the region in the first octant, the first octant bounded by y square plus z square is equal to 9 and x is equal to 2. See, very very interesting problem. Very interesting problem. You will just do this problem now, right? See, in a two-dimensional plane, we have four quadrant. Two-dimensional plane. First, second, third, fourth. First will be positive, positive. In second quadrant, your x is negative, y is positive. That you all know. Similarly, for 3D surface, you have 8 octant. Right? For 2D, you will say quadrant. We will have four quadrant in 2D. In 3D, we have 8 octant. In first octant, all are positive. In second octant, x will be something, y will be something, z will be something. I already explained the previous classes. So just as of now, we just think that for a 2D, you have four quadrants. Each quadrant, your x and y will have some signs. And similarly, for 3D, you will have 8 octant. Here in 2D, you will say quadrant. In 3D, you will say octant. OCTANT. So here we have 8 octant. In the first octant, x is positive, y is positive, z is positive. So we need to verify Gauss divergence theorem for this solid in the first octant. In the first octant, right? Okay. So we'll do this, right? Very, very interesting problem. We'll do this, right? Let me draw the diagram first, then you will understand this easily. See, I will take this as my y-axis, this as my z-axis, this as my x-axis. Just for the convenience, right? Because we have y square plus z square is equal to 9. So it is a circle with the center 0, comma 0 and a radius 3 on yz plane. So just to draw diagram easy, I'm just taking this, right? Just to draw diagram easy, I'm just taking this. That's it. Let us take, right? So we'll draw this and we'll draw one more. So we have, right? So we have one solid, and this is y square plus z square. Y square plus z square is equal to 9. And you can see this top is x is equal to 2, right? This top is x is equal to 2. See, you have top, right? The top is x is equal to 2. That is the upper bound. The lower is x is equal to 0, right? Yes. Now we need to do this only in the first octant. We need to do only the first octant. So we need to verify this theorem only in the first octant, right? So we'll take only the first octant now. So we'll take only the first octant now, right? Okay. Let me try to draw only the first octant, right? Where your x is positive, y is positive, z is also positive, right? Okay. So I'm just drawing only the first octant now. Right? So we have only the first octant now, right? It is 3D. Just visualize this, right? We'll take only the first octant. Now, first what we'll do is we will find surface integral, right? That is what tricky part is. Volume integral is very easy, right? Volume is very easy. Now we will find the surface integral first now, right? So first what we need to verify. So we need to prove double integral over S f vector dot n cap ds is same as triple integral over V del dot f vector dv. This is what we need to tell, right? So first we will do this part now, right? Usually we will do volume integral first, then we will do surface integral. Okay, let me do the procedure, right? So first we will find the um first we will find the volume integral, right? Okay. So first we will find the RHS. So RHS is triple integral over V del dot f vector dv. Now we make a divergence of this. So what is del dot f? Multiply this component, sorry, differentiate part with respect to x. It will be 2y will be constant, x square is 2x. So we will have 4xy with respect to y minus 2y with respect to z. It will be 4x is constant, 2z. So we will have 8xz dx dy dz. See, we are doing only in the first octant, right? We are doing only the first octant. So therefore, your y will not be y will well sorry. This is a circle, right? So this is center, this is radius. So radius is 3. So y varies from 0 to 3 alone. It will not vary in that. So you should not vary y from minus 3 to 3. You should vary only from 0 to 3. So it is in the first octant only, right? So in the first octant, you can see this y will not come that side. So only this side will come, right? So don't vary minus 3 to 3. Vary only from 0 to 3 because it is only the first octant, right? Okay. So now we will find dx dy. We need to find the limits for dx dy dz. So we will do that, right? We will do that. Okay. Now, um, x varies from 0 to 2, right? X varies from 0 to 2. That we know. X varies from 0 to 2. And uh, what about yeah, z? See, you can z varies from you can treat one as variable, other vary from 0 to 3. So if I vary z varies from 0 to 3, your y square will be 9 minus z square. So y will be plus or minus root of 9 minus z square, but you don't take both because y varies from 0 to this only, right? So you can either choose z varies from 0 to 3 and you can vary y. You can vary y, or you can choose y varies from 0 to 3 and vary x. But here I am doing, I am taking z varies from 0 to 3. Just a minute. Just want to remove that white portion. Okay, let me leave it as it is, right? What I'm doing here is I'm varying z from 0 to 3. So z from 0 to 3, right? Z from 0 to 3, and I'm varying y as a variable. Treating y as a variable, y varies from, see, you should not take plus or minus, it will only from 0 to, because since it is first octant, right? I'm doing like this. So 0 to root of 9 minus z. Is it clear, right? So usually we will write plus or minus 2 plus, but it is in first octant, your x is positive, y is positive, z is positive, right? Yes. Now you have to evaluate this integral. So integration of 4xy minus 2y plus 8xz dx dy dz, right? Now you just have to integrate this, right? With respect to x, with respect to y, with respect to z. So here what I can do is, okay, let me integrate with respect to x now. So this will be 0 to 3. will be 0 to root of 9 minus z. So 4y integration of x dx is x square by 2 minus 2y integration of dy is x plus 8z integration of x is x square by 2 dy dz, right? Dy dz. So we will have this to be 2x square y, 2x square y minus 2xy, 2x square y, 2x square y minus 2xy, 2x square, 2x square y minus 2xy. This will be plus 4x square z plus 4x square z dy dz, right? Dy dz. Now we need to integrate with respect to y now. This will be 2x square will be constant. So integration of y dy is y square by 2. 2x is constant. Integration of dy is y square by 2 plus 4x square z. Integration of dz is dy. Dy is y. So you will have dz now. So z varies from 0 to z varies from 0 to 3. This 0 to root of 9 minus z, right? Okay. So these two will get cancelled. So z varies from 0 to 3. X square y square minus xy square plus 4x square z into y. So upper limit minus lower limit. So 0 to root of 9 minus z, right? So we need to put it in y, right? We need to put it in y. This will be, I can take x square, just a minute. I think I made some mistake. 4x. Okay, I think I forgot to put x limits, right? See, I think I forgot to put x limits. So x limit is 0 to 2, right? So this x varies from 0 to 2. I forgot to substitute x limits. Before that, I have integrated with respect to y. So this will be, the upper limit is x square. So 2 into 4y minus 2y into x plus 4z into x square is 2 square dy dz. This will be 8y minus 4y plus 2 square 16z dy dz, right? 4y minus 8y. I'm just putting upper limit to be 2. So 2 square here will be 2. 2 square is 4. 16. Yes. It will be integration of 4y plus 16z dy dz. Let me take 4 outside. It will be y plus 4z dy dz. So with respect to z varies from 0 to 3. If I integrate with respect to y dy is y square by 2 plus 4z integration of dy is y. So 0 to root of 9 minus y. So this will be 4 times integration of 0 to 3. So 1 by 2 z square is 9 minus y plus 4z into root of 9 minus y dz. 9 minus z square, sorry. Now I am making mistakes. 9 minus z square. Right? Now we need to integrate this again, right? We need to integrate this again. So what we can do is, let me multiply this 4 inside. Let me multiply this 4 inside. So this will be 4 by 2. So 2 times integration of 0 to 3. 2 times integration of 0 to 3, 9 minus z square dz plus, let me multiply this 4 here. So 16 times z into, sorry, 16 times integration of z into root of 9 minus z square dz. Right? So we need to integrate this to get the answer for volume integral, right? Okay. I think it's very clear, right? So here it is actually uh, 9 minus z square. So forget to put z square. So y limit is 0 to root of 9 minus z square. Sorry. So just substitute x limits, integrate with respect to y, upper limit minus lower limit, and again with respect to z we need to integrate. Okay. So this is 2 times. So 9 into integration of dz is yes, z 0 to 3, z square is z cube by 3, 0 to 3 plus 16 times integration of 0 to 3 z into root of 9 minus z square dz. This will be 9 times, this will be 27 minus, so 3 cube is 27 by 3, so 9, 27 minus 9, so 9 into 27 minus 9 is 18, so 18 into 9, uh, 18 into 9, 8 nines are 72, 9 ones are 9, 9 ones are 9, 9 plus 7 is 16. So this will be 162, right? So 3 cube 3, 27 minus z cube by 3, 0 to 3. So 3 cube is 3 square is 9, 18. Yes, now we need to perform this integral now. So for this, what I will do is we need to do by substitution. So put t is equal to 9 minus z square. So what will be your dt by dz is minus 2z dz. So your z dz is dt by minus 2, right? Dt by minus 2. So I can put this as z dz is, so here we have 16 z, so this will be root of 9 minus z square is t, z dz is dt by minus 2. Now we need to change limits, right? So we need to change z to t. So when z is 0, your t is 9 minus 9 minus 0 square, which is 9. And when your z is 3, your t is 9 minus 3 square, which is 0. So this limits varies from 9 to 0. So this will be 2, this will be 8. So we will have 8 times integration of 9 to 0 root t dt minus root t dt. See, this limit is 162, right? So we will have minus 8 times integration of 9 to 0 root t dt. This limit is 162, right? Sorry, this answer is 162. Now this is same as, I can change this to 0 to 9 and put it as plus. Let me put this as plus and change this to 0 to 9. Right? So changing the limits will change the, this negative will get, sign will be changed. So this will be 162 plus 8 times. So t power 1 by 2 integration is 3 power 3 by 2 by 3 by 2, 0 to 9. Right? So t power 1 by 2 is t power 1 by 2 plus 1 divided by 1 by 2 plus 1. So this will be 162 plus 8 into, so t by 2 will become 2 by 3. This will be 9 power 3 by 2, right? Upper limit minus lower limit. So this will be, I think it is correct, right? So 2, 8, let me try. This will be 162 plus, this is 16 by 3. This is 27, I think, right? Because I can write this as 3 square. 2 will get cancelled. So 3 cube will be 27. I think you're not getting the answer. So 2 times 9 minus z square, 0 to 3. 9z minus z cube by 3. Just see where I have missed, right? So 27 minus 3 cube is 27 by 3. So 27 minus 9. Even for the 9s are. So 18 into, okay, this is 2, right? Why written 9? So 2 times 9, 2 times 27 minus 9 with 36. Will be 36 with 36, right? So 3 ones are 3 nines are, it will be 36 plus 16 nines are, it is 144. So yes, so 180 is your volume integral. Is it clear up to now? So 180 is your volume integral, right? Sorry, I don't know why I'm making small minor many mistakes. So this will be 2 times. So 2 times this will be, so 180. So 180 is your volume integral. Now we need to find surface integral, right? Now we need to find the surface integral. See, there are how many faces here? How many faces here? Just me, let me draw that, right? How many faces here? Because see, so we have this bottom surface, right? We have this bottom surface, and we have the upper surface, and we have the upper surface, right? And also we have the left surface. We have the left surface. Also we have the right, this right surface, right? Right, or you can see this back surface, right? See, there is a back surface at the back, and then we have the curved surface. So overall we have 5 surfaces here. Is it clear? Overall we have 5 surfaces here, right? So let me call this as bottom surface. So bottom surface is your S1, right? And your top surface is S2, and you have a left surface. So left surface is S3, and we have the back surface which is S4, and then we have the curved surface which is S5. So we have 5 surfaces now, right? So bottom, up, left, then back, and then this curved surface. See, just visualize this in 3D, right? So left, up, down, this left, and then this back portion, and then this curved surface, right? This curved surface. So we need to evaluate these 5 surfaces to get the surface integral. To get the surface integral. So therefore, sorry, here I have made some mistakes, right? Sorry, I wasted your time. So this will be double integral over S f vector dot n cap ds. So this will be double integral over S1 f vector dot n cap ds, right? Plus double integral over S2 f vector dot n cap ds plus double integral over S3 f vector dot n cap ds plus double integral over S4 f vector dot n cap ds plus double integral over S5 f vector dot n cap ds, right? Now what is your S1? S1 is your bottom, right? This is your bottom, and this is your top surface, and this is your left surface, and this is your right back surface, and this is your curved surface, right? This is your curved surface. Now you can see, first we will try to find n cap, right? First we will try to find n cap for all this. Now what is your n cap? Now what is your n cap? What is your n cap? What is your n cap? For all this we will try to find. See, for curved surface, n cap is del phi by mod del phi, right? See, for bottom surface, what is your n cap? See, n cap is this thing which is opposite of x. So your n cap will be minus I vector. Yes or no? For bottom surface, see, my axis is changed now, right? Here I'm writing y, z, x. Usually we will write x, y, z, but just for understanding this diagram, I've changed the axis now, right? So y, z, x, remember. So you can see this is your unit normal n cap, which is parallel to x in opposite direction. So your n cap will be minus I vector, and for upper surface, your n cap will be same as x direction, which is I vector. This is minus I vector, that is I vector. Yes or no? This is minus I vector, this is I vector. Is it clear up to now? Now for the for this down surface, what is your x is 0, right? For this your x is 0, and for this your x is 2. For this your x is 0, and for this your x is 2, right? Yes. Now for left back. Now for left, what is your n cap? See, for your left, this is your n cap, right? This is your left surface. So n cap is this. Yes or no? N cap is this, which is what? Which is opposite of z axis. Yes or no? Which is opposite of z axis. So your n cap will be minus k vector. Yes or no? See, left for this left surface, this is your unit normal. So which is opposite of z, parallel to z axis, opposite direction. So it will be minus k vector. So it will be minus k vector. And for your back surface, what is your n cap? See, for back surface, your n cap will be like this, which is what? Opposite of y. Opposite of y. So which is minus j vector. Yes or no? See, for back surface, this is your unit normal, which is opposite of y. So minus j vector is your n cap. This we will find later, right? This we will find later. Now, for this your x is 0, x is 2. Now, for left surface, you can see this left surface lie on xy plane. Yes or no? This lie on xy plane. This left surface lie on xy plane. Yes or no? This left surface lie on xy plane. So, if it lies on xy plane, your z will be 0. Yes or no? So, it lies on xy plane. On xy plane. On xy plane. So therefore, your z will be 0. And what about the back? Which plane it lies? Which plane it lies? This back lies on xz plane, right? Xz plane. So xz plane. So y will be 0. Xz plane on xz plane. So your y will be 0, right? Okay. Now let me try to find f dot n cap. Let me try to find f dot n cap. Let me try to find f dot n cap. Let me try to find f dot n cap for this. Now what is f dot minus I? So f dot minus I. So f dot minus I. So minus 2x square y. Minus 2x square y. So this will be minus 2x square y. And what is f dot n cap for this left? So n cap is minus k. So f dot minus k. F dot minus k. So f dot minus k will be minus 4x z square, minus 4x z square, minus 4x z square. And what is f dot n cap or back? N cap is minus j. So f dot minus j. So f dot minus j will be plus y square, plus y square, right? And we know x is 0. So if you put x is equal to 0, this entire interval will be 0. Here we have minus 4x z square and we know z is 0. So this interval will be vanished. Because 4x into 0, you don't need to integrate this at all. And for this y is 0 and the surface f dot cap is y square, this will be vanished. So we have only the top surface and the curved surface we need to evaluate. Is it clear? See, actually there are 5 surfaces, so 3 of them get vanished. So we need to evaluate only S21, this is S5. So S5 is your curved surface. Now we will try to find one by one. So therefore, double integral over S f vector dot n cap ds is same as the top surface f vector dot n cap ds plus the curved surface which is your s5 f vector dot n cap ds. Now we need to we will find these two, we'll add it up, you will get what? You will get 180 because we know that volume integral is 180. Is it clear? Very easy, right? Okay, now let me try to find S2. S2 f vector dot n cap ds, and we know we already found what is n cap, right? So n cap is n cap is I vector, x is 2, n cap is I vector, x is 2, and your ds will be what? Dy dz. If it is not curved means, you directly write, if you have I, you just put dy dz. If you have j, you just put dx dz. If you have k, you put dx dy. This we already know. So therefore, now what is f dot n cap? It is f dot I. So what is f dot I? So your f dot I is 2x square y, 2x square y, 2x square y, ds is dy dz, and we know x is 2, right? X is 2, there will be 2 square, so 2 square is 4, 4 2s are 8, so 8 times integration of y dy dz. Right, now what is your y limit and what is your x limit? So y varies from 0 to root of 9 minus z square, z varies from 0 to 3, right? Z varies from 0 to 3, so this will be 8 times z varies from 0 to 3, so integration of y dy is y square by 2, 0 to root of 9 minus z square dz. So this will be 2 1s are 2 2s are 4. So 4 times integration of 0 to 3. So y square will be 9 minus z square dz, right? 9 minus z square dz. This will be 4 times. So 9 into z cube by 3, 0 to 3. This will be 27 minus 9. So 3 cube, 27 by 3 is 9. So 18 into 4. So 72 is your top surface. 72 is your top surface. Now you know that the volume integral is 180, right? So you know your volume integral is 180. This S2 surface is 72. So 180 minus 72. So you'll get 108 will be the answer for this. Without even calculating, you just try to put 3 to 4 steps. Just put 108 in the exam point of view. Time save. So this has to be 108 because we know this integral is same as the volume integral. Volume integral we have got 180. This we have got 72. So this has to be 108. But we will do this. Now we will find S5. So S5 f vector dot n cap ds. Now this is a curved surface, right? So your n cap will be del phi by modulus of del phi. So what is your n cap? So n cap is del phi by modulus of del phi. And what is your surface? Surface is what their surface they have given. So it is y square plus z square, right? Yes, y square plus z square minus 9. So del p is 2y multiply with respect to x, sorry, partial differential with respect to x multiply I vector. So your I vector will be 0. I component will be 0. So it will be 2y j vector plus 2z k vector, right? 2z k vector divided by root of 4y square plus 4z square. See, just have to find del phi. So del phi is dou by dou x of this component into I vector, dou by dou y of this component, right? This function into j vector. See, dou by dou z of that into k vector. So dou by dou x of this is 0. So 0 I vector. Dou by dou y of this is 2y. So 2y j vector. 2y. This is a formula for gradient, right? So here I can take 4 outside. So y square plus z square is 9. So 36 root is 6. So if I take 2 outside, we have yj plus zk divided by 6. So 1 by 3 yj vector plus zk vector is your n cap. Now what is your ds? So ds can be dx dy divided by n cap dot k, or it can be dy dz divided by n cap dot I, or it can be dx dz divided by n cap dot j. Now you don't choose this. If you choose this, there is no I. So that means it will be 0. So you can either choose this or this, right? Let me choose dx dy divided by n cap dot k to be ds. Dx dy divided by n cap dot k. So dx dy divided by, if you make a dot product with the k vector, you will have z by 3. You will have z by 3. This will be 3 by z dx dy is your ds. And what about your f vector dot n cap? What is f vector? It is given in the question. So 2x square y I vector. See, for curved surface alone, you have to do like this, right? I think it will be comfortable for you. Plus 4x z square k vector dot n cap. So n cap is y by 3 j vector z by 3 k vector. So make a dot product with this. I component is 0. So minus y square into y by 3 plus 4x z square into z by 3, right? So we will have this to be minus y cube by 3 minus y cube by 3 plus 4x z cube by 3. 4x z cube by 3. See, already know 108 is going to be the answer, right? So in exam point of view, just try to find this, and if you feel that problem is long, just do 1 or 2 steps and put that is equal to 108. Now we will evaluate this. So f vector dot n cap ds. What is f vector dot n cap? Minus y cube by 3 minus y cube by 3 plus 4x z cube by 3, 4x z cube by 3, and your ds is 3 by z dx dy. 3 by z dx dy, and we know your y varies from dx dy. So x varies from 0 to 2, y varies from 0 to 3, right? Y varies from 0 to 3. That's it. Now you need to evaluate this integral. So this will be integration of 0 to 3. We multiply this z here. See, we should have dx dy. We should have dx dy, right? Okay, let me try to multiply this z. This 3 will get cancelled. So you will have minus y cube by z. Again, this 3 will get cancelled. Z will get cancelled. We'll have 4x z square dx dy. So minus y cube by z plus 4xz square. And we know z is root of 9 minus y square, right? Because we should not have x z here because here variable only should be in terms of x and y. 0 to 2. So this will be 0 to 3, 0 to 2 minus y cube divided by root of 9 minus y square. This is your z. 4x z square is 9 minus y square dx dy. Dx dy. Right? Yes. Now we need to integrate with respect to z, sorry, with respect to x and then with respect to y. Okay. Now we'll integrate with respect to x. So this, see, you cannot apply the idea of even odd function because the limit is from 0 to 2. If it is from minus a to a only, we can apply that idea, right? So don't put this to be 0 as it is odd function. It is odd function, but the limit is not from minus a to a. It is from 0 to 2, right? Yes. So this will be integration of 0 to 3. So integrate with respect to x. There is no x term here, right? There is no x term here, so we will be minus y cube x by root of 9 minus y square. So integration of dx is x, right? Integration of dx is x, and then integrate with respect to x here, 4x square by 2 9 minus y square. The limit is from 0 to 2 dy, right? Yes. So upper limit will be 2. So 2 times integration of 0 to 3 minus y cube divided by root of 9 minus y square dy. This will be 2. Upper limit is 2 square. So 2 square is 4. 4 by 2 is 2. 8 times integration of 0 to 3 9 minus y square dy. Is it clear, right? So I'm just putting upper limit x to be equal to 2. So 2 square is 4. So 2 by 4 by 2 is 2. 2 into 4 is 8. Now we need to perform this integration, right? So this is 2 times integration of minus y cube divided by root of 9 minus y square dy plus 8 times integration of 9 minus y square dy. So it is from 0 to 3. That varies from 0 to 3, right? What we are doing, we are substituting x limits, right? But we are not in, sorry, yeah, I mean integrated with respect to y now. Y limit is what? Just a minute. First we are integrating with respect to x. So with respect to x, so y varies from 0 to 3. Correct only, sorry. 0 to 3, upper limit minus lower limit. Yes, correct only. Okay. Now we need to perform this integral, right? We need to perform this integral. This is very easy, right? Just 9 dy minus y cube by 3, upper limit minus lower limit. Now to perform this integral, let me do some substitution, right? So put d is equal to square root of 9 minus y square. So what about dt by dy? So root x is 1 by 2 root f of x into f dash of x. So you have minus y divided by root of 9 minus y square will be your dt by dy. It, dt by dy. So your dy minus y dy is square root of 9 minus y square dt. So minus y dy is root of 9 minus y square, right? Let me write this y square as y square into y. So I can write this y dy as, see, just a normal integration. So 2 times integration of, here, minus y square into y dy divided by root of 9 minus y square, right? Let me take this as, let me take this as I1, let me take this as I2, right? So this is I1 plus I2. So first you will evaluate I1, right? So this is, so y dy. So what is y square? So t square is 9 minus y square. So y square is 9 minus t square. So let me keep this. Okay, let me take this minus y dy because already we have minus here. So minus y dy is, okay, just a minute. So y square is 9 minus t square, right? Y square is 9 minus t square minus y dy is root of dt by dy, right? So this is t, this is t, and what about minus y dy? It is root of 9 minus y square. I think you are making some mistake. See, here we have y square into y. So t is root of 9 minus y square. This will be t. So dt by 1 by 2 root f of x into f dash of x. So this is minus 2y. So 2 will get cancelled. So we have minus y divided by root of 9 minus y square. Minus y dy is root of 9 minus y square dt. So this will be root of, okay, what we can do is, let me write this. Yes, root of 9 minus y square is what? So root of 9 minus y square dt, and this root of 9 minus y square is t. So this 2 will get cancelled. So you will have 2 times integration of 9 minus t square dt. Limit is changing now. So we are changing y in terms of t. So when y is 0, what is your t? T will be root 9, which is 3. So we are in only first octant, right? Take that as 3. And when y is 3, your t will be 0. The limit is from 3 to 0, right? Now just perform. See, very easy, right? You just have to integrate this. So minus y square, I'm writing this as y square into minus y dy. I'm putting t to be root of 9 minus y square. So root f of x. So not derivative of root f of x, right? So root f of x derivative is 1 by 2 root f of x into f dash of x, chain rule, right? The dy dx of root f of x. So I'm just applying root f of x is 1 by 2 root f of x into f dash of x. So perform this integration now. I can write this as minus 2 times integration of 0 to 3. I'm just changing the limits and multiplying by minus. So 9 minus t square dt. So this will be minus 2. 9 into dt is t. So 927. T cube by 3. It will be 9. T cube by 3. 27 by 3, which is 9. So this will be minus 2 into 18. So minus 36 is your I1 integral value. So minus 2 times 0 to 3, 9 minus t square. So 9t, so 9 3 minus t cube by 3. So 3 cube by 3, 27 by 3, which is 9. So minus, that's your I1 value. Now we will find I2. So I2 is 8 times. I2 is 8 times integration of 0 to 3 9 minus y square 0 to 3 9 minus y square dy. So 8 times so 9y 0 to 3 minus y cube by 3 0 to 3. So 8 times 27 minus 9. So 27 minus 9 18. So 18 into 8. 8 8 are 64. 8 ones are 8. This is 144. So therefore integral double integral of we are finding S phi, the curved surface, right? The curved surface is S phi f vector dot n cap ds is I1 plus I2. This is minus 36 plus 144. This is 108. Yeah, we already know this is going to be 108, right? So therefore, double integral over S f vector dot n cap ds is S2 plus S5 top plus curved, other all are 0, others all are 0. So what we got here, this is 72. 72 is your S2 and 108 is your S5, sorry S5. So this is 180. So therefore from 1 and 2, Gauss divergence theorem is verified. I'll repeat, right? I'll repeat what we have done. See, first we need to check we will take the question. See, we need to verify Gauss divergence theorem for this vector field taken over the region only in the first octant bounded by y square plus z square is equal to 9 and x is equal to 2. So I'm just making this as y z x axis. So we have y square plus z square is 9. So it is a circle with center 0, radius 3. And at the top, bounded by x is equal to 0, x is equal to 2. And we need to find only in the first octant. So first we will find volume integral. So triple integral over v del dot f divergence of f dv. So just make a divergence of f dv. So you were see the only thing is the limits y limits are 0 to 3. Z or you can take z limits to 0 to 3, you can vary y, or you can take y limits to 0 to 3, you can vary z. That is your wish. So I am taking z varies from 0 to 3 and I am varying y. So what is y? Plus or minus root of 9 minus z square. But you take 0 to root of, because we are in first octant. First octant everything is positive. So this is your y. So 0 to root of 9 minus z square, and z varies from 0 to 3. So and x varies from 0 to 2. These are the limits. Substitute those limits, right? So these are the limits. After finding the limits, very easy to evaluate the triple integral. You will get the answer to be 180. See, you have to put y limits here, z limits here. I'm not putting that, right? Y limits here and z limits there. See, this is y. This y limit z varies from 0 to 3. Y limits varies from 0 to root of 9 minus z square. Right now again we integrate, take 4 outside, integrate with respect to y, upper limit minus lower limit. So we will get 180 to be the answer for this. For here I'm just putting e to be 9 minus z square. So this will be z dz. So these are just 12th standard mathematics. This is very easy. This will get 36. This after substitution you will get this to be 144. 36 plus 144 will be 180. So 180 is for volume integral. Now to find surface integral, there are 5 surfaces here. Just write those 5 surfaces. The bottom is your S1, top is your S2, left is your S3, back is your S4, and then you have curved surface. So for S1 your x is 0 and for S2 your x is 2, and this S3 lie on xy plane, z is 0. This back surface lie on xz plane, so your y will be 0. Right? So depending based on all this data, you can cancel out S1, S3 and you can cancel out S1, S3 and S4 because on that z is 0. So f dot n cap will have z alone. So it will get vanished. It will get vanished. So you will have only the top surface and the curved surface to evaluate to find surface integral. Now you evaluate top surface, you will get 72 as your answer. and you evaluate the curved surface. For curved surface, your n cap will be del phi by mod del phi. Your ds will be this. Now evaluate this. You will get this to be one. Uh, you will get this to be 108. Yes, add it up. So volume integral is same as surface integral. So therefore, Gauss Divergence theorem is verified. Right? Very interesting problem. Just understand and study. It will be very easy. So we'll stop here. Light is also issue there. So I'll rectify that light in the next class. We'll continue in the next class. Thank you. All the best.